Okay, so for the holes command, what we're going to be doing is creating this object here. I've already made the block. Now we just have to go over how to put the holes inside of the block. So as you can see, I've made the block already, and we're just going to use this drawing file here to create that. So in order to place the holes, I'm going to start a sketch on top of my block, and it looks like I'm going to need three holes here. So I'm going to um, use the point, and I'm going to place 3 points on my object. Um, After this, I have to dimension these things. So we're going to go and horizontally constrain all of these, and then constrain those to the center point because they're on center here. Then I'm going to take this middle one, pop that on the middle, my coincident constraint, and then just dimension 1.25. And then my last one is 3.75. So now I have a fully constrained sketch with 3 points on there that I can use for my three holes. So go ahead and finish this sketch. And now we're going to start using the hole command. So in here, I'm going to click my hole command. What it's going to do is bring up the dialog box that I can use to create all the holes that I need. As far as input geometry goes, we're going to start with our first hole here. So I'm going to select my first hole. If all of your holes came pre-selected, go ahead and under input geometry here, there'll be an X here that you can close out so that you can select just the point that you want. So I'm going to select my first hole here. I'm going to read my diagram here. So my main hole here is a 0.35 diameter that goes down 0.75 inches. That would be the main shaft of the hole here. And then as far as the seat goes on my second line, I can see here I've got the symbol for a countersink, and my countersink has a diameter of 0.5 inches at 82 degrees. So there's no thread designation here, so I know that the type of hole that I'm going to be using is a simple hole. And then my seat type is going to be countersink because I'm going off of this countersink symbol here. Um, then I just have to enter in my values. So my main hole diameter is 0.35. My main hole length, 0.75. And then the diameter of my countersink is 0.50. And 82 degrees is the default, so I can leave that as it is. And then this is a drill point, I can tell here. So I can leave that as the default as well. I can click OK. So now I have my first hole created. You will notice now that since I created a hole there, the sketch that I had all those points on has gone away because it was used for my first command here, my hole command. So if I hit the plus sign next to my hole command, I can right click on sketch for and turn on the visibility, and then my points come back. And then when I'm finished at the end, I can shut those off again. So go back, we're going to look at our second hole. So for my position, I'm going to click on my middle hole here. And if I look at this one, it looks like I have a 0.25 diameter hole that goes all the way through. There is no thread designation here, so I know that's a simple hole. And then my seat is a countersink. I could tell by that um, symbol right there with a 0.45 inch diameter that goes down 0.25 inches. So my hole type is simple hole, and my seat is a counter bore. Be careful, don't use spot face. Spot face looks very similar to a counter bore, but it will give you a different value. So now it's just a matter of entering in my values. So as far as the main hole goes, the termination, instead of a distance here, it says through. So I'm going to change my distance to go through all for my main hole. You'll see the distance goes away from my diagram here. And then it's just entering in my information. So I have a 0.45 seat on my counter bore. Let's change that to 0.45. It goes down a quarter inch, which is already set there. And then my main diameter was 0.25 through. So 0.25. Click OK. And now I have my second hole created. Lastly, I'm going to work on my third hole here. So my third hole, I'm going to select this here. I have one line of text here, so I know that it's just a single hole. There is no seat, so no countersink or counterbore. You can also tell by looking at it that there is no seat here. So I'm going to turn off seat. And then as far as the size goes, and the actual designations here, it goes all the way through, and it's a 3/8 by 16 UNC. So, reading my thread designation, I could tell that I have thread designation from UNC there. So this was a 3/8 inch diameter with 16 threads per inch, unified national coarse thread. So instead of a simple hole in this case, because I have a thread designation, I know that I'm going to need a tapped hole, and that will allow me to have thread designations in here. No seat, so this is a 3/8. So in order to get 3/8, I have to do that into a decimal. So I know 3/8 is 0.375. And then I can check my thread designation, 3/8 by 16 UNC. 3/8 by 16 UNC is correct there. 2B is a class, that's the default, and it goes all the way through. So I am going to go to my termination to make it all the way through. The last thing that I have to check is if my threads go all the way through. Unless it says otherwise, you can assume that your threads go all the way through. You can also tell by looking at this section view here that these dashed lines here that run parallel to the hole go all the way down. So I know that my threads are full depth. So that gets rid of the thread depth designation here. So I already said the hole goes all the way through and the threads go all the way through the hole as well. I can click OK. Um, Now I can turn off that sketch 4 visibility that I used to get those points back so I don't cloud up my object here. And if I want to check, a good easy way to check and see if it looks correct is if I click in my model browser on part 1, what I like to do is then go ahead and change the material to something clear. And then I can kind of look at it from the front and see if it matches what my section view looks like. So I can go to here, select clear blue. Then I can line up and make sure that it looks the way that it should. Okay, so if I'm looking at that and comparing that to my actual view of what my schematic is supposed to look like, those match up. So I can be confident that those are all correct.